Hello everybody and welcome to today's live stream in which I'm going to attempt what I already attempted with the yes and no module before. This time we have a challenge module called Goofy's Game, which is here on the workshop. This is what the module looks like. It appears to be a number module with LEDs. So the first thing we're going to do is we're going to take a look at how the module behaves. So we're going to look at it on a live bomb. And then I'm going to use decompiling to try and figure out how the module works. So I've already moved the Goofy's Game module to my mods folder. So if I run the game now, it should have only that module on it. But there is a good chance that I won't be able to decode it easily. The reason I say that is because the community took quite a while to figure this out, without decompiling though, obviously, but that is what I'm trying to do first. And also because Goofy said that he intentionally made this module in such a way that it would not be easy. Alright, let's see. On the left we have ... so that's a 3. And by the way, this is the first time I'm seeing this module. I did not know that it would be Morse code, but I recognize it quite easily. So that's ... that's a 7. And then we have ... That would be a 9. So we have Morse code for 379. So what happens if I just type 379? Of course, that is incorrect. Right, so obviously I could just try, all possible numbers. But that would just take forever. I'm guessing that the answer is probably several digits. Hello Goofy, welcome to the stream. This, ladies and gentlemen, is the author of the module we're looking at, Goofy1807. And you can judge for yourself the quality of his work. I mean, so far it looks really good, like in terms of its visuals. The Morse code is very smooth, the texture looks pretty cool. And the font is kind of nice. I think this is the same font as in I don't remember the other module that you made, but anyway. Alright, so I guess I'm gonna head straight into the decompiler and take a quick look at this module. Alright, yes and no is still in the list, let's get rid of that. And let's go to my mods folder, which has Goofy's Game in it and the DLL. Alright, now I expect this to be an interesting challenge because Goofy promised me that it would be. Let's see if I have any other stuff open that I might want to close. No, I think this is fine. Alright, so here is the module. Let's see, you have a button masher module, bomb creator example. I think you might probably want to delete the examples from your modules. Example gameplay room, you probably don't need all of these things in your module, Goofy. In fact, not even probably, you don't need these things. Delete the examples. So presumably okay, so none of these is called Goofy's there is Goofy's Game script, I just didn't see it. Alright, here we have the script file, which has KPP, intentionally obfuscated names here. KP, imp. Well, imp is probably input, and btn is probably button. Alright, $this is interesting. Okay, not quite sure why that happened. This seems like the kind of thing that would happen if you run an obfuscator over your assembly. But looking at this code, it doesn't look very obfuscated. So I guess we'll have to take a we're gonna have a conversation about this, like what you did to the assembly. But first, let's find out what this code actually does. So at the start, obviously we set the module ID like we always do, and then here we already access something called KP. Aha! So this is something that is assigned in Unity. So we have a KP array. And by the way, Goofy, since you're in the chat, you can answer this question. Am I allowed to look at the log file? Because I just ran the module once and I typed in some numbers. Am I allowed to look at the log file to see, maybe it output a message or something? Um, I just realized, yes, okay, good. I just realized that there is a Twitch place handler here, which may reveal quite a lot about the kinds of things that you can do on this module. No. Yes, no. Okay, please make up your mind. Can I look at the log file, yes or no? um, so let's see. So apparently I can type in literally just a number and you can only have up to 33 digits. 33 additional. Oh, right, no, plus, right, okay, so the current, okay. So, this num here, this is what the user typed in the TP command. So for each number here, we press that button, and then wait. So this is literally just entering a number. Right, and then we have the delete button, and then another number. That is surprising. You are trying to, oh, I see, you can press it a certain number of times. Okay, so that number of times it will press the delete button. So now we know that kp of 10 is the delete button. So that's quite interesting. I would normally have a separate field for the delete button, but since this is a challenge module, it makes sense to obfuscate it in these kinds of ways. This is cool. And then of course there's the submit command, which does su. So obviously su is the submit button. Okay, so that was the Twitch place handler. Now let's take a look at start. So for every button, okay, so this just sets, so KPP is the button press handler for the buttons, and then this is the submit handler. We'll get to that in a second. I expect this one here to be very simple, because there we go. If this is the clear button, then it just removes the last letter from the thing. Otherwise, it will not allow you to put more than 33 digits. Let's see, this .inp. Yeah, okay, so inp is obviously the input, and we just add the digit that, oh, I see, so the index of the button is also the digit that you're entering. That makes sense. Set screen obviously just sets the text and the color. Okay. Go back here. So this one, interesting that the decompiler turns this into byte.max value, which is of course 255, but I imagine that you probably put 255. So this always sets the screen to white. Alright, now let's take a look at what the submit button does. Actually, let me see what the rest of the start method does, because there's... Okay, so this is the press handler. This is where the submit button press handler ends. And here it does 3 things. So we have a list of integers called LC. I'm assuming, yeah, that is a lowercase l. And we put numbers from 0 to 9. So this is probably the digits flashed on the LED. Light code emitter. Okay, so you have 3 separate coroutines, 1 for each. Yeah, see, this just does the Morse code blinking. And apparently you use these integer manipulations to calculate what the Morse code for a digit is, instead of just having an array. But that's okay. 0.8 and 0.2. This should probably be 0.6, because in normal Morse code, the length of a dash is supposed to be 3 times the length of a dot, and also the length of the gaps between them. So this should probably be 0.6, and the length of gaps between letters in a word is supposed to be, I think it was, yeah, that's the same as a dash, but between repeats of the word, I think it's 7 times. So in this case, that would be 1.4. Alright, so if you want to make those changes, it's up to you really, but having 0.8 and 0.2, it's totally readable, but it's not standard Morse code. Alright, and this one here looks like just a victory animation, Vic as in victory. Yeah, that just sets the LEDs to some random things. So, there is a do it function here. I'm gonna check what the do it function does first. Okay, so obviously these are the LEDs. I don't even need to remember that. Okay, so we start with the string builder. We add the first character of the string that is passed in. You don't need this part. You can just say substring 1, and it'll just... Okay, so if the input is, let's say, for example, programming, then after the first step, the character C is going to be P, and then it removes that and adds a space at the end. Okay, num equals 1, and then for each character in n, so for each of these characters including the space, if that is not equal to the original one, so every character that is not equal to the P, we add that. Okay, num, okay, so I see. So to the string builder, we add the digit 1, and then the character C, which in this case, yeah, so that's just P. Okay, and then the number becomes 1 again. I see. So we end up with 1P and then 1R, 1O, 1G, 1R, 1A, 1M. And now we have the first repeat of a digit. So this time that will not be true. So it just increments the number, which means that we now get a 2, and then the next character, which is I see. And then 1G, and then at the end we will have the space. Except, no, we won't, because, no, we will. Okay, so for each character in n, which still includes the space, so the second last time, when this character is still G, we append the number 1, which is the count of n's, and then the G. So there will be another iteration of this, so it will have one space at the end. Interesting. Okay. So I'm calling it now. My theory is that this function will go over the serial number or something. And we will find out about that. Okay, so let's see what the start method does. In fact, let's see if there have been any comments. No for the log, that would help you decompile. Okay, I will not look at the log. Hello, Brawlbox, welcome to the stream. Okay, so the start function does this. Hi, Goofy. Okay, so we have a random number that is either 0 or 1, so that's you know, a random boolean basically. So let's say so num is a random boolean, and if interesting. So if num turns out to be 0, then none of this happens, which means that everything is at defaults, which means I can only see what this will be. Oh, I see. The 0, I can't remember if 0, so 0 should be the button that enters the digit 0. So what this is doing is it's moving the 0 button to the position of the delete button, so it just swaps the delete button, the 0 and the delete button. Alright, so mode is going to tell me if delete and 0 are swapped. Okay, that's a boolean that tells me whether that is true or not. Okay. By the way, I hope that you guys can read the code. I'm gonna increase the font size a little. I probably should have done that sooner. I apologize. I will try and remember that next time. Yep, okay. So the next thing it does is it takes the letters in the serial number and adds. Oh, I see. So it turns them into numbers. So the alphabet becomes, you know, A1Z26, and that becomes a list. And then, of course, the digits becomes a separate list. And then for each, oh, I see. And then, okay. You can abbreviate this, by the way. Instead of this for loop, you can say list.addRange list2. Right, and since the list2, do you even need the list2? Yeah, you're not using the list2 anymore. So you can literally just put this in here, and then that will work. Just a minor suggestion. Okay, so we now have a list that contains all the letters and then the digits from the serial number. And of course the letters are converted, and then the digits are normal. Okay. Num2 is going to be the battery holder count plus indicators plus the number of port plates. If we are not in this swapped mode, then R, which is just a string, is LC. I should have written down what LC was. Ah, okay. It's a list of 3. Oh, of course, the LED numbers. Okay. So the first number plus this. Ah, okay. So I'm gonna call the LED numbers A, B, and C. Okay, so this is A plus all of that times, and then we have B plus the sum of the items in the serial number, so the order doesn't even matter. So I'm just gonna put it like this. I think there's a, yep, there you go, the sum of the serial number. And then after that we have plus C, and then plus num2 again. Now I can, yeah, okay, so let's, okay, so we're just gonna, you know what, I'm gonna call this n. So let's call that n, and that is plus n. Else, okay, so if mode is true, then that's that. False, which means swapped or not swapped. Else it is this, which means A plus the sum of the serial number digits. That. Times, and by the way, I want to use a time sign, thank you. B plus that number, plus C plus again the sum. Okay. There we go. Okay, so depending on whether the 0 button and the delete button are swapped, you know, it's interesting because I don't actually know what the default position of the 0 and the delete button is, so I'm going to have to use trial and error to figure out which orientation is the swapped one and which one isn't. So that's an interesting one. Okay, now we have, oh, we run do it 4 times on this. Okay, so this algorithm, so R is a string. I see, okay, so you stringify this number, okay, and then you, yeah, so you do it 4 times. Oh, now I remember. This is from a number sequence that is a common sort of puzzle. Yeah, there you go. The look and say sequence, that's what it's called. Okay, so this puzzle, this module deals with the look and say sequence, which describes, so each element here describes the previous element by saying, so there is a single 3, and then a single 1, and then there are 2 2s in a row, and then there are 2 1s in a row. So that's how that works. So apparently now you can look in the log. Okay. Very good. So that's what the look and say sequence is. So let me check if that is all that we need to do. If the input is equal to that, then pass. Yep. Okay, so in order to pass the module, I just need to run the look and say sequence 4 times. And that's it. And then it starts a victory animation. Else, if the length is too big, your number has X. So why this random thing? It seems to me that both of these pieces of code are exactly the same. Am I missing something? Ah, it says either Goofy's sequence or Goofy's game. I don't know if that's intentional. You know, maybe you're thinking that if I do look at the log file analyzer, I wouldn't notice that. Wouldn't notice this because it wouldn't be filed under Goofy's game. So if that was an attempt at obfuscating, then obviously I will notice that here in the code. Conway's game. Incorrect. I see. Okay. But your digits are wrong. Okay. So that gives you a strike. It just says incorrect, and that's it. Okay. So I believe that now I know how the module works. I'm going to try it. So I don't think we need any of this. Goofy's sequence and Conway's game. Goofy's game and question mark. Okay. So I need to figure out which orientation is the swapped one. So let's figure it. I'm just going to calculate both of these numbers and then see what happens. Okay. So first of all, the sum of the serial number digits is 11 plus 2 plus 13 plus 3 plus 0, 29. And then this number, oh, I removed the, I think I remember this. This was battery holders plus indicators plus port plates. Battery holders plus indicators plus port plates is 5. 1, 2, 3, 4, 5. Yes. Okay, so n is equal to 5. I should probably write this down up here. There you go. So n is 5. Okay, so if the mode is swapped, then this number... Oh yeah, I need A, B, and C. Okay, let's take a look at this. Dot, dot, dash. Oh, I see, the green. Dot, dash, dash, dash. So, okay, so A is 1. Take a look at B. That's 7. I'm going to check that. Dash, dash, dot, dot, dot. Yep. And then we have... That's a 0. Dash. Oh no, it's a single dot at the start. So that's a 1. So we have 171. Which means that if it's swapped, so okay, so this is a 1, this is a 7, and this is a 1. And then of course n is 5. And the sum of the serial number digits is 20. Okay, it changed the n inside that. Okay, so this is 29. Okay, so this is equal to 222, which, okay, I'll do the sequence afterwards because I have to do it 4 times, and this is 390. Okay, so 1, 2, 3, 4. So the first time here, this is 3 2s. Actually, wait, I'm still a little confused by the thing with the space, because so the doit function, it never removes that space at the end, does it? Oh, this is clever, because it only does this when it encounters a new and different character. So it adds the space at the end in order to trigger this for the last character. So for the space, it will only do this and not actually add that to the string builder. This is cool. Very good. So that's a 1 3 1 2. That's a 1 1 1 3 1 1 1 2. And then the fourth time we have 3 1s 1 3 3 1s 1 2. And by the way, Goofy, I don't know if you realize this, but this sequence will never have a number greater than 3 in it. So technically, your module doesn't actually need all the other buttons. Those would just always be wrong. Okay. So not swapped has this 1 3 1. Oh, you do start with digits other than 1 2 and 3. So actually, it will have other digits. Never mind. Hello, Eric. Welcome to the stream. That's 1 1 1 3 1 1 1 9 1 1 1 0. It's quite long. Then we have 3 1s 1 3 3 1s 1 9 3 1s 1 0. And finally we have 1 3 2 1s 2 3s 2 1s 1 9 1 3 2 1s 1 0. Okay, so let's try this one first. 3 1 1 3 3 1 1. And then a 2, and that was correct. And we can see the solve animation here. Very good. Okay, so that means that it was swapped, and I forgot to write down where the delete button was. So I have to do this again. Okay, so we'll just do it again. No worries. Okay, so the sum of the serial number and n. Alright, n is probably still going to be 5. I strongly suspect that my number of widgets is just always set to 5. So that's still 5. And this is 24, 25, 31 plus 3 plus 8 is 42 plus 5. Oh, 47! We have the best number. Okay. Now A, let's make this smaller again. dash, dash. Okay, it ends in 2 dashes, and it starts with dashes, so that's actually a 0. Then we have dot dash, that's a 1, and that was a 6. Dash, dot, 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 yep, that's a 6. Okay, so let's go back to this. Let's copy these formulas again. And in this, I'm going to change A, and this time I'm going to use match case and whole word only. A becomes 0, B becomes 1, C becomes 6, N becomes 5, and the sum of the serial number digits becomes 47. Right, so this is going to be 251, and this is going to be 335. Now this time I'm going to write down the position, so delete is in the bottom right. Okay, now 251, that's 1 2, 1 5, 1 1, and now we have 1 1, 1 2, 1 1, 1 5, and then 2 1s. Then we have 3 1s, 1 2, 3 1s, 1 5, 1 2, 1 1, and finally we have 1 3, 1 3, 2 1s, 1 2, 1 3, 2 1s, 1 5, 1 1, 1 2, and 2 1s. Let's try this. 1 3, 2 1 1. That's up to here. 2 1 3 2, 2 1 3 2, 1 1 5, 1 1 1 2 2 1. And that was correct, which means that this means delete is in, okay, the delete button is in the bottom right, and the alternative is top left. Okay, so let's try a module where the button is in fact in the top left. Let's just open 5 modules. Okay, in all of them the delete button is in the top left. Okay, so here let's take a look at these Morse codes. That was a 3, and I believe that was also a 3. Nope, it's a 0, and that was a 6. Dash, dot, yep, that's a 6. Okay, so let's get our formulas again. Right, I should probably write down the delete button in the bottom right versus the top left. So this time it's in the top left. Okay, the sum of digits in the serial number, I mustn't forget to update that. That would be 11, 14, plus 7 is 21, plus 8, 29, 33. I hope that was correct. So this is a 3, this is a 33, which is 36. Bravo is a 0, plus 5 is 5. So this is 180. Charlie is 6, and that would be 39, so we're at 219. Okay, so the first time I do the sequence, we get 1 2, 1 1, 1 9. Second time is 1 1, 1 2, 3 1s, 1 9. Then we have 3 1s, 1 2, 1 3, 2 1s, and 1 9. And the fourth time we have a single 3, 2 1s, a 2, a 1, a 3, a 2, 2 1s, and a single 9. I wish I could copy and paste this straight into the module, but I can't. I have to type it in. 1 3 2, 1 1 2, 1 1. We're here. 1 3 1 2, 2 1 1 9, 2 1 1 9. Aha! That was incorrect. I guess at this point I can look at the log, because maybe I just wrote one of the numbers down wrong. Let's see. Find. Okay, since this sometimes changes, I'm gonna do this and search for either of the two. Ooh. Ah, okay, there we go. Goofy's game incorrect. Oh, it doesn't actually log the input. Yeah, that's all it does. It just says, okay, so I just have to try it all again. Let's see. The sum of the serial number digits. Maybe I calculated this wrong. 10 plus 1 is 11, plus 4 is 15, plus 7 is 22, plus 8 is 30, so this is 34. I did calculate this wrong. Okay. So let's just try this again. Okay, let me make sure that the LEDs don't change after a strike. A is supposed to be 3, yep. Bravo is still 0, and Charlie is a 6. Okay, so the numbers don't seem to change. 3, 34, that would be 37, times 5, that would be 150, 185, plus 6, plus 34, which is 40, so that's 225. So we have 2 2s and 1 5, then we have 2 2s, 1 1, 1 5, then we have 2 2s, 3 1s, 1 5, and then finally we have 2 2s, 1 3, 2 1s, 1 5, and the answer would be 2213, 2115, solved. Okay, I believe that's it done. So with that, with that determined, I'm going to now look at the manual. Actually, before I do that, Goofy, would you like to confirm that I've discovered everything there needs to be discovered? If there is anything else, please let me know now. I'm going to look at the manual in a second. In the meantime, I'm just going to scroll through this code. Yes. I'm going to assume yes means I can look at the manual. Okay. Let's see. Of course, it's possible that the manual is not on the website yet, so I'm going to look at the manual challenges. Okay, there is a zip file here. Let's open this and put this file in my HTML folder. So I can go here, this one, and open it. Alright, this module shows 3 LEDs, a display, 11 circular buttons, and a submit button. Find the correct sequence to submit following the rules below. First, obtain the 3 numbers represented by the LEDs flashing in Morse code. X is the sum of the characters in the serial number. Y is the total amount of widgets. Non-modded widgets, really. If the delete button is in the top left position, your number is that. Otherwise, swap all occurrences of X and Y. Ooh, okay. Right. And then calculate your new number. Okay, iterating the sequence. Start with the number obtained in the previous step. For each set of consecutive numbers, take the amount of digits in the section and concatenate. I think I'm going to copy edit this a little and change some of the fix some of the typos. In fact, I'm going to do that now. Right, repeat this process 3 more times and then submit the answer. Okay, so let's go here. In fact, let me make sure that the apostrophe in the file name is correct. There you go. Let's change all occurrences of this. Normal match case, 3 occurrences. Okay, on the subject of Goofy's game. This should not be like that. This module shows 3 LEDs, a display, 11 circular buttons, and a submit button. Find the correct sequence to submit, following the rules below. Obtaining numbers first. First, obtain the 3 numbers represented by the LEDs flashing in Morse code. Call the first number A, the second number B, and the third number C. What a coincidence, by the way, that I called the numbers the same thing you did. I could have called them X, Y, Z. Calculate your number using the rules below. Don't forget it's in the zip. I guess I'm gonna do that afterwards. The sum of characters in the serial number. For letters, take the alphanumeric, alphabetic. It's in the alphabet. The alphabetic position. Y equals total number of... Yeah, I think I'm gonna just abbreviate it like this, because otherwise this might confuse people who have modded widgets on. If the delete button is in the top left position, your new number is this. I'm going to add some spacing here. And also those parentheses on the outside are not necessary. Otherwise, swap all occurrences of X and Y in the previous formula and then calculate your new number using this formula. Start with the number obtained in the previous step for each set of consecutive numbers. For each set of... okay, take the amount of digits. This is a bit, I know what you mean because I know how the look and say sequence works. I'm not quite sure if this wording is clear to someone who doesn't know it. But I'll let other people worry about that. Concatenate the values of these digits, e.g. 111, 221, 3 ones, 2 twos, 1 1. Then append all these values. So that's concatenate. Repeat this process 3 more times using your new number. There's a full stop missing here. Submit the number you've obtained, and that's it. And /div. Alright, okay, there you go. Alright, let's refresh this. Of course, because I changed the apostrophe. Okay. There we go. That works. Alright, now let's open that zip file again. Actually, I already have it open here. Let's take the... Okay, lots of stuff in here that really that's really not required. Let's put that here and fix the name here. No, I didn't need to open Inkscape. I wanted to open this website. Let me actually open the SVG first. Yep, it's huge. Paste that here, copy that, make that very small, and then use my regular expression to make it even smaller. That doesn't seem to have made any difference. Yep, it didn't. Okay. I guess because I'm not quite sure why you need all these group. Yeah, you really don't need these, but honestly, I don't care right now. So I'm just gonna leave it like that. And now let's go to Google Chrome, create the PNG for that. The PDF. My apologies. I want to go here. You know what? I'll just copy and paste this. There we go. And just make that into a PDF. Goofies. Okay, I mistyped that. I'm waiting for Chrome to finish. There we go. It's finished now, and it has appeared here. goofiesgame.pdf. There we go. And now we can open the Git repository. Don't need Inkscape, and submit that to the website. Okay. Let's make sure that no one else has submitted something like this already. In fact, let me see if it's been posted to the requests channel. Ooh, there's quite a lot of requests here, but nothing relating to Goofy's game. So I'm just going to submit it. Let's see if there is something. Alright, a lot of changes have been made. Let's just merge those. And then submit this. Goofy's game. Now, before I submit this, I should probably add a JSON file. So let's just do that. Save this as Goofy's game.json. The author is, of course, Goofy, and I suspect that you probably want me to use the same name as okay, so this one doesn't have the numbers after it, so I'll just put Goofy. Diffuser difficulty is easy because in fact, I would say it's very easy because you only need to. Oh wait, you do need to read the Morse code. So I'm gonna call that easy. Calculate a number and modify it according to the look and say sequence. Tags, LEDs, 3 LEDs, Morse, 11 buttons, no, actually 12 buttons, the delete button and the submit button in addition to 10 digits. And I guess digits, because there are digits on the buttons, and del, because there is a delete button. The expert difficulty, I would say, is still easy. The module ID, I can figure this out. The module ID should be... wait, I can figure this out without looking at the Git. Let me just remove the tutorial video so I don't forget. This is definitely a candidate. Let me find I think considered is the word that I used. Let me find any other JSON where it is considered, so I can just copy and paste this bit of JSON code, put that here, and say Souvenir could ask about the 3 digits that flashed in Morse code. There you go. Let's close this. Okay, so what I can do is I can do this. No, not mod settings, mod info. Look at Goofy's game, and there we go. It is Goofy's game without apostrophe and without... And in fact, this is also going to be the sort key, so I'm just going to use that. The name is Goofy's game. It was published, presumably... was it published today or yesterday? If it was today, then that would be 0511. Source URL. I'm going to assume that this is probably here. No, it is not. Okay, let's find that. Yesterday, okay, let's change that to 10 then. Okay, it looks like it is not yet on GitHub, but I have a strong suspicion that it is going to be under this name, Goofy's-game. Hello Mac, welcome to the stream. Alright, the Steam ID, we have that here. That's this number. I think I want to close the game. Symbol, okay, so we need to check if GG. GG is probably already taken, isn't it? Let's switch to the here. Interesting, GG is not actually taken. So I guess we'll make it GG. And while we're at it, M and N's doesn't have a symbol, so I'm going to add that as well. Let's see if MN, that is the moon. Maybe the moon could just be M? No, math is M. MAN? Okay, MAN is not taken. Let's see what the other... okay, so let's call it MNN then. MNN, there you go. Make sure that's not taken. It is not taken. Very good. Back to Goofy's game. That can be GG. And I think that's it, right? It's not a boss module. It does have Twitch Plays support. Which isn't in this JSON anymore, so I don't need that. Right, this is obtained from a spreadsheet. What else is there? Mystery module. Yeah, it can be hidden just fine, so it doesn't need that. I think that's it. I think that's all that we need. It doesn't need an ignore list. Okay, so we can submit this now. So let's take this file, stage it, and then of course this I will do separately. Goofy's game. Let's see. Can you give my parvos on Fort? I have no idea what that means. Please say Conway sequence instead of look and say. Oh, you want me to change the description like that. Okay. Conway's sequence. Is that what it's called? Conway's sequence. Let's find out. Yep, bingo. That is just another name for... let's see if that's mentioned right here. Oh, it's not mentioned in the first sentence, though. There we go. The Conway sequence. Okay, so it just says there that someone else called it that. According to the Conway sequence. That's what it called it. Alright, so let's actually submit this. And let's squish that with the previous change. Okay, it wants me to submit this first, so add symbol for M and N's. Let's do that. And then let's squish those two. And then, so here's the thing, right? I want to, let's create a branch. I'm going to show you what I want to do. See, the thing is, if I force submit this now, I have to force submit in order to get rid of this old change. But if I force submit this now, then the changelog channel will just simply say that I did a force submit, and it doesn't actually show the actual changes. So I want to do the force submit on Goofy's game first. So I'm going to set master to Goofy's game, reset to hard, yes. And then I'm going to do the git push -f. And now I can show you what this looks like. It'll just say, there you go, it just says branch master was force push, but it doesn't tell you what the changes were. So now I want to merge this in, and then push that, and then it will tell me what it will, tell the channel what the actual change was that I added the symbol for M and N's. There we go. So now I can get rid of this temporary branch that I created. I can close this. I can close this. I can now close the decompiler because we're done with that. And I guess I can close the stream because we're done. The manual should now be on the website. Let's find out. Goofy's game is right here. Someone needs to make an icon for that, but I don't generally do that, so I defer to other people for that. And we're done. So thank you very much for watching. I hope that you enjoyed the stream. And if you would like to, if you would like me to try and decode another module without looking at the manual, send me your suggestions. I'm happy to take a look. I haven't played any of the last probably like 200 modules or so that were created. So if any of those you think is an interesting challenge, then just let me know. If you have any comments, questions, concerns, or suggestions, feel free to leave them in the comment section below if you're looking at this on YouTube, or drop me a line on Discord. I will hear your suggestion after the stream. Thank you very much for watching, and I will see you around. Goodbye.